So let's go ahead and find the exact value of arc cosecant of 2. That could be rewritten at, which is theta, right? Our cosecant of theta is 2. Well, cosecant is 1 over sine of theta. So now I have 1 over sine of theta is 2. 2 equals 1 over sine theta, because we substituted in for cosecant. I multiply both sides by sine of theta. I get 2 sine of theta is 1. I divide both sides by 2. So we find sine of theta is 1/2. Now's when it's important to know what quadrant we're in. Note that I can only be between -2 pi and pi over 2. So my only quadrant options are 1 and 4. Those are our possible quadrants. Because cosecant, which is 1 over y, is positive, that tells me I'm in quadrant 1. So sine of theta is 1/2. That's going to be when theta is, if I'm looking at my unit circle, theta is pi over 6, because that's where I have a y value of 1/2. Let's go through another example. Let's say I have this arc secant of 8. That means that the secant of theta is 8. Well, secant, remember, is 1 over cosine theta. So I'm going to rewrite this as 1 over cosine theta is 8. And I'm going to isolate cosine, so I get cosine of theta is 1/8, which is something I can calculate, right? I can calculate that in a calculator, right? The reason I'm converting them to cosine and to sine is because there isn't an arc secant button in our graphing calculator. So I punch this into my graphing calculator and I'd get about 1.45. Next, let's take a look at the cosecant of -2. That means that the cosecant of theta is -2. Well, cosecant is 1 over sine of theta. So I get 1 over sine of theta is -2. So sine of theta is -1/2. This implies that arc sine of -1/2 is going to be our theta, and we get about -0.52. It's important to note that I did skip a step here, right? We do have to rewrite this as, in order to figure out our theta, we have to rewrite this as arc cosine of 1/8. Gives me my theta, which I calculated to be 1.45. Sorry about that. Next, what if I want to find the arc cotangent of 1/5? So cotangent of theta is 1/5, okay? That means our cotangent is positive, where cotangent has the same possible thetas as tangent. So our only options are between 0 and pi, so quadrants 1 and 2. But because cotangent's positive, we know we're in quadrant 1, where this will be defined. Cotangent is 1 over tangent. Again, using our trig identities. This is going to simplify down to tan of theta is 5. So I rewrite this as an inverse where it's arctan of 5 is theta. And we'll get about 1.37. Let's do one final example using cotangent, and we're going to have to solve this a little bit differently. So if I have the inverse cotangent or arc cotangent of 1/2. This is going to be a negative 1/2. That tells me that cotangent of theta is negative 1/2 because cotangent is negative. We're going to be in quadrant 2. Okay? Here's the thing though. Tangent is not defined over here, right? Tangent is only defined from quadrant 4 and quadrant 1. So we have to use a different method. We can't use tangent. We can't use arctangent. So I'm going to draw a circle, right? Here's my theta. I know that y is 1 and x is 2. That means our hypotenuse this is going to be the square root of 5, right? And I'm just trying to figure out theta, right? And theta isn't defined over here, but cosine is, right? Cosine's defined in this quadrant. I couldn't use sine because sine, well, it'd be sine is -1, but sine of -1 is theta, but we're in quadrant 2, and sine inverse would only work in quadrants 1 and 4. So we could rewrite this as cosine of theta is -1 over the square root of 5. That means we could solve that cosine inverse of theta, arc cosine of 1 over the square root of 5 is our theta, which is going to be about 2.03. So that's why it's really important to know what quadrant you are in and where your functions are defined. Last but not least, here are our fundamental trig identities. We need to get really comfortable using these because what we're going to start doing is we're going to start writing trigonometric expressions as an algebraic expression and using u substitution. So here I've got cosine of arc cotangent of u. So let's let theta equal arc cotangent of u. So that means cotangent of theta equals u. So I've got cosine of cotangent theta. Well, those cotangents are going to cancel out, so I'm just left with cosine of theta. And now what I'm trying to do is, now that I've gotten rid of the cotangents, I need to get this back into terms of cotangent, because then we can use this u substitution, right? So I need to make this all cotangents, right? And I know that seems counterintuitive because I used arc cotangent to get rid of our first cotangent. That's okay. So cosine of theta, if I multiply that by sine of theta over sine of theta, that's going to give me cosine of theta over sine of theta times sine of theta, if I wanted to rewrite it. Well, remember that this is cotangent. So now if we go over here so I make sure I have tons of space, I've got cotangent of theta times sine of theta. Well, sine of theta we could rewrite as cosecant. So sine of theta would be 1 over cosecant theta. Now I have cotangent theta over cosecant theta. Well, we've got a little handy-dandy trig identity that cosecant squared theta equals 1 plus cotangent squared theta. So I could go ahead and take the square root of both sides, and then I have cosecant of theta is the square root of 1 plus the cotangent squared of theta. So now I have, this turns into cotangent theta over the square root of 1 plus cotangent squared theta. And then I can substitute RU back in. So I'd be left lastly with U over the square root of 1 plus U squared. Now, that may have seemed very foreign, okay? We get rid of the cotangents, then we make it so that we can write it exclusively in cotangents to use this substitution method. The only way for these to make more sense and come across a little bit easier, in my opinion, is to practice. There's a few of them on the worksheet, and I'd be happy to go over those if you ask me to. Please remember there is a guided note sheet for this section. I probably should have said that at the beginning. And if you have any more questions on section 6.2, please drop them in the comments and I will answer them in turn.